For this example, we want to find the volume of the solid formed by revolving the region that is bounded by x equals negative y squared minus 4y and x equals 3 about the line x equals 3. So in order to do this, we're going to have to get a decent graph. So you guys have been struggling a little bit with these sideways parabolas, so we want to pay really close attention because some of us still have some work to do on area between curves. You want to make sure that you're comfortable graphing these. So we're going to take just a basic XY axis system here. And since it's a sideways parabola, we can still treat it and make a table of values the same way we could a regular parabola. Just we're going to be choosing the y values rather than the x's. So to find the vertex of a sideways parabola, if you can't tell just by looking at it, it's still opposite of b over 2a, but you're just looking at what's in front of the y's instead. So this will be your b. So opposite of that would be 4 over 2a, which would be negative 2. So 4 over negative 2 would be negative 2. And then you just take negative 2 and substitute it in to find the x value that goes with it. So that will give us negative 4 plus 8, I believe. So I think it's positive 4, but would someone check me on that? If we substitute negative 2 into the parabola there? Guys, can I get a little help here? I think it's positive 4.
Yes.
Yes, positive 4. Okay. And then what we need to do to graph a parabola is we just need to pick a couple of points around the vertex. So because we want to pick our y values, we want to pick negative 1, 0, negative 3, negative 4. So negative 1, 0, negative 3, negative 4. And that'll give us a good idea of what that sideways parabola looks like. So we're going to pause and let you guys see if you can get that table filled out, and we'll get that graphed. So what we find when we substitute negative 1 is we get positive 3. And here, if we substitute 0 for y, we get 0. The negative 3, does it produce positive 3 again? And the negative 4 produces 0 again, right? Okay, so those are the points we're going to use to graph our sideways parabola. Let's see. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so we have 4, negative 2, 3, negative 1, 0, 0, 3, negative 3, and 0, negative 4. So here's our sideways parabola. Well, should have been, I kind of missed there. We have this. So is it a little easier now that we've kind of gone through it for you to figure out how to graph a sideways parabola? Hello? Yes? We're okay with that? Okay. From there we need to add the line x equals 3. Is that a vertical line or a horizontal line? Vertical. So x equals positive 3. 1, 2, 3. So we're running this line right here. And what we want to do is we want to find the area trapped between them, or the region trapped between them. So that's going to be this region right here. So we'll put it in yellow. This region right here, that's what we're going to be revolving. So inside there is where our rectangle needs to go. So far so good? I want to revolve it around the line x equals 3. So that is a vertical axis of revolution, which means I need to draw my rectangle perpendicularly this way. So here's my rectangle. So it is a vertical axis of revolution, so we're going to go with respect to y. So we'll set up our integral to calculate volume, and the volume is pi times the integral from c to d, which we haven't officially calculated yet. But guys, we can see them right here. What's the y value right here? And what's the y value right here?
Negative 3.
Negative 3. So we should be going from negative 3 to negative 1, right? You could also get that by setting the two boundary functions equal, not functions, boundary graphs equal. So we have negative y squared minus 4y equals 3. Then we'll get that equal to 0. And we'll factor it. And you should be able to see those two limits of integration pop up. And sure enough, we see that this is negative 3 and this is negative 1. So if you don't have like a really perfect perfect graph, if you're just going from a sketch, that's the way you get those limits of integration. So from -3 to -1. Remember that the larger goes on top and the smaller goes on bottom. Then we have to take the radius squared. So the capital R squared is the height of this rectangle. And the way you do that is you take this graph minus this graph. So it's a lot like what you set up when you calculate area between two graphs. So the outer graph there is the parabola. So that will be -y² minus 4y. And we'll subtract the line, which is 3. So we have -y² minus 4y minus 3. And that has to all be squared with respect to y. Remember that that's our formula. Pi, the integral from your lower to your upper limit of integration, times the capital R squared with respect to your variable. So we'll pause right there because it's going to take you guys a couple of minutes to square this out. We have to square it out because we don't have anything that we could sacrifice there. So we can't just do the power rule. We're going to have to square it out, distribute, and then do each piece separately. So we went off to the side and we found that this guy distributed out yields positive y to the 4th plus 8y cubed plus 22y squared plus 24y plus 9. And that's with respect to y. So we just need to integrate each piece separately and substitute in the upper and lower limits. Equals pi. So 1/5 y to the 5th, right? Right?
Yeah.
Okay. Y to the 5th over 5. 8y to the 4th over 4. So that would really be 2y to the 4th, right? This would be 22y cubed all over 3. And this would be 24y squared over 2, so 12y squared. And finally 9y. And we need to evaluate that between -3 and -1, sorry. Okay, so let's see what we can get. If we substitute in the -1, shouldn't be that bad. We'll leave our brackets here for now. So the -1 gives us -1/5 plus 2 minus 22/3 plus 12 minus 9. So that's our first parentheses. And then from there we're going to subtract whatever we get when we substitute -3 in. So help me out here, guys. What's -3 to the 5th? Anyone? -3 to the 5th?
It is.
I have no idea at this point.
I got you.
-243.
-243?
Yep.
Okay, so that's going to be -243 over 5. And this one, -3 to the 4th, is 81 times 2 is 162. -3 to the 3rd is -27 over 3 is -9. -9 times 22. You guys could help me. What is it?
-198.
180 plus 12. No, plus 18. -198? Yeah, -198. And then finally, I need to substitute the -3 into, where am I? This one? -3 squared is 9. 9 times 12 is
180.
108. And then minus 27.
Yay.
Okay. So all we have to do now is calculate that into a single fraction of pi. So we simplified this guy right here, and we got -38 over 15. And then the second parentheses yielded -18 over 5. And together that simplifies to what?
16
Positive
pi over
16 pi over 15. So I think that's probably the most difficult one we've done as far as algebra goes. Any questions on it? No? Okay. So for your problem set for this on your syllabus, I wanted you to do problem 16 as well, but it wasn't on your syllabus. I think that's the one I left off. So be sure you add that. There will be 10 problems to turn in the next time I see you.
That's achievable for me.
I think it is.